All right. So these were the problems you sent me, and I'll go ahead and walk through them. This was the first problem, and let's see. Let's go ahead and read through it. It says that the graph shows the estimated number of milligrams of a pain medication M in the bloodstream T hours after a 1,000 milligram dose of the drug has been given. Estimate the 1 hour interval over which the absolute value of the average rate of change is the least. Enter your answer using interval notation. Okay. So the average rate of change, remember from the last video, average rate of change is the slope. Okay. And what I mean by that, let's look at between 1 and 2 hours. So between 1 and 2 hours. If I were to draw a line between those 2 points, let's start at 1, go up, it's this point right here. Then go to 2 hours is right here. If I were to draw a line between those 2 points, the slope of that line represents the average rate of change. And you can see, that slope appears to be about at 2. It goes up 2 and over 1. And that's between 1 and 2. Look at 2 and 3. Let me change my color. 2 is right here, and 3 is right there. If I draw a line connecting those 2 points, the slope of that line represents the average rate of change between 2 and 3. And let's keep on doing that. Between 3 and 4, 3 is right here, 4 is right here. If I draw a line between those 2 points, that represents the average rate of change between 3 and 4. And look at that blue line. You see how it's flattening out compared to the red and black lines? When it starts flattening out like that, it means that the slope is decreasing, which means the average rate of change is decreasing. So between 3 and 4, the slope is less than between 1 and 2 and between 2 and 3, because that line is getting flatter, which means the slope is decreasing, which means the average rate of change is also decreasing. So between 3 and 4, that's pretty flat. That's a pretty small slope. But let's look at 4 and 5. Let's go between 4 and 5. Change my color. Here's 4. Here's 5. And if I draw a line between those 2 points, you see how it's much steeper than the blue line? That means the slope is greater, which means the average rate of change is greater. And if I look at the last interval between 5 and 6, if I draw a line there, you can see that this line is really steep. So what you're looking for is the smallest slope, which is going to be the smallest average rate of change. The smallest slope is the blue line because it's the flattest line. The flattest line has the smallest slope, has the smallest average rate of change. So the interval that blue line occurs is between 3 and 4. 3 and 4. So your final answer, it wanted interval notation. Yeah. Interval notation looks like this. I know it's between 3 and 4. So you're going to do parentheses 3 and 4. Just like that. Between 3 and 4. That's where that 1 hour interval has the smallest average rate of change. And we know that because it had the smallest slope. Going down to B. Looks like you got B. Yeah, you got B right. I see the green check down there. But let me just talk about it real quick. it says over what interval is the average rate of change approximately equal to the rate of change at t equals 4. I'm going to erase everything I have. Okay. Instantaneous rate of change is going to be your tangent slope. So right here it says the instantaneous rate of change at t equals 4. What I do is I go up from the 4 until I hit the graph right there. And the tangent slope is going to be the line that goes through that point. It's going to be kind of like that. That'll be your tangent slope. It's tangent to that point. That's your instantaneous rate of change. So remember, in calculus, whenever you see the words instantaneous rate of change, if you have a function, it means you need to find the derivative. If you have a graph, it means the tangent slope. And then I'm going to read the second part. Average rate of change on 2 to 5. So it says both the instantaneous rate of change at t equals 4, which we just drew, and the average rate of change on 2 to 5. Let's look at that. That's interval notation. It means you have 2 points, x equals 2, x equals 5. X equals 2 and x equals 5. Well, if I go up from the 2 and hit the graph, it's about right there. If I go up from the 5 and hit the graph, it's about right there. And if I connect those 2 points, that's your average rate of change. Average rate of change is the slope between 2 points. And it says that those two slopes are about equal to 0. And yeah, that's true, because if you remember a horizontal line, its slope is 0. And these two lines are approximately horizontal. I mean, they're not exact, like this one's not exactly horizontal, nor is this one, but they're really close to being horizontal. So yeah, they are about equal to 0. Horizontal line has a slope of 0. So yeah, you got that one right. Let's keep on going. This one right here. This question is just asking about this function right here. And you're given choices of how do I take the derivative. And let me just make sure this is what it's asking. Consider the function below. Yeah, it's just giving a bunch of information. Product rule. Select letter P would require the product rule. Q if it requires the quotient rule. C if it requires the chain rule. And some functions may be combos. PC or QC. So you may select more than one letter. If the problem does not require product, quotient, or chain, select S for simple. Okay. So if I look at this first one, that function right there, this is, if you remember from our last video, this would require the chain rule. Whenever you just have a variable brought to a power, and between them you just have addition or subtraction, that's going to be what's called the power rule. And I know they don't have that as a choice. I'm assuming they mean that simple is the power rule because it's so easy to do. So let me show you the power rule real quick. And I think that was a 4. I can't see it anymore. Yeah, it's a 4. So it's going to be plus t to the 4. The power rule just says take that power, bring it to the front. So now it's 2t, and then subtract 1 from the exponent. 2 minus 1 is 1. Drop down to plus. Again, bring the power to the front, 4t. Then subtract 1 from the power, 3. That's the power rule, which they're calling simple. So that's that one right there. And we'll see what product, quotient, chain rule are in a second. Then it says differentiate. I'm down here on this next problem. It says differentiate the function using the method that you selected. Well, we just did that. because that's the same function, and I just differentiated it right here using the power rule, which they call simple. They're calling it S simple. Hold on a second. Here we go. Is that the same one? Question 2. Hold on one second. T squared, t to the 4. Oh, I see. Yeah, we just differentiated that. And what we got was, you remember that was what I just did. Brought the t to the front. I subtracted 1. I brought the power to the front. I subtracted 1. So the choice that matches that is, let me see. Let's see. It's this one right here. When you differentiate that, you get that. Remember, if you have a 1 as a power, you don't have to write it, which is why you don't see that 1 on that t right there. If you have a 1 as a power, you don't have to write it. Let's go down to 3. Hold on one second. Here we go. So now we're looking at this function, and we have to determine what rule we use to differentiate that. Is it the product rule, the quotient rule, the chain rule, or that what they're calling simple, which is the power rule? This is the chain rule. And let me show you exactly what the chain rule is and how to recognize it. The chain rule is when you have composite functions. Composite functions are when you put one function inside of another function. Okay, so chain rule is used on composite functions, and composite functions are when you put one function inside of another function. So to show you what that means, let's look at this function right here. And let me show you how this is a composite function, which means I'm putting one function inside of another function. And one function, by the way, is called the outer function, or the outside function, and the other function is called the inside function. Okay, so one function will be inside of the other. One of the functions is the outside function. The other function is called the inside function. That's going to make sense here in a second. So watch this. If I look at this function right here, ignore this stuff right here for just a second. All that stuff in red, ignore it. I'm just going to call the stuff in red, I'm just going to replace it with a box. I have something to the 5th power. I have something to the 5th power. And again, that something is what I'm ignoring. It's this stuff right here. It's that function. That something is a function. W4 minus 2W is a function. But for now, I'm just going to ignore it. So I have something to the 5th power. That's your outside function. Something to the 5th power. And your inside function is the something. In this case, W4 minus 2W. That's your inside function. So there are two functions here. There's the outside function, which is something to the 5th power. That's your outside function. And your inside function is the something. Is this stuff right here. W to the 4th power minus 2W. That something is the inside function. It's been put inside of the outside function, which is something raised to the 5th power. That's how you recognize the chain rule. You have one function being put inside of another function. One function is the outside function, the other function is the inside function. That's your chain rule. Chain rule. Okay? And I'm assuming we're going to differentiate that here in a second. Yes, we are. So let's go ahead and use the chain rule to differentiate that function. All right? Now, when you're using the chain rule to differentiate a function, you remember I just said that if you have a composite function, you use the chain rule. A composite function, you're putting one function inside of another function. One function's the outside function. The other function's the inside function. Here's what you do with the chain rule. I'm just going to kind of repeat it, kind of tell you what it is at first, and then we'll actually do it. With the chain rule, when you want to take the derivative using the chain rule, the first thing you do is you take the derivative of the outside function. Then you evaluate that at the inside function. And then you multiply it by the derivative of the inside function. Now that sounded kind of complex, but it's really not as hard as it sounds. So watch this. You remember I just said this is the inside function, and I called it something, and I replaced it with a box. Let's go ahead and do that again. This is your something. That's your inside function. For a second, I'm just going to ignore it. That's my inside function. I'm just going to ignore it, and it's being brought to the fifth power. This is your outside function. Something brought to the fifth power. That's your outside function. And the first thing you do on the chain rule is you take the derivative of the outside function. That's the first step in the chain rule. You take the derivative of the outside function. Well, the derivative of the outside function, I'm just going to use the power rule. I'm going to bring this power to the front. So it's going to be 5. And then it's going to be that something, which we know is the inside function. And then with the power rule, I subtract 1 from the exponent. So it's going to be 5 times something raised to the 4th power. So we just took the derivative of the outside function. That's what I just did there. I took the derivative of the outside function. The next step in using the chain rule is you evaluate it at the inside function. Okay, so you take the derivative of the outside function and you evaluate it at the inside function. This was the inside function. This right here, that stuff in red. W to the 4th minus 2w is your inside function. So what I'm going to do is I'm going to take that inside function and I'm just going to place it inside of this derivative that I just took. Okay? So again, I took the derivative of the outside function. That gave me this. Evaluate it at the inside function. And there's one last step with the chain rule. Then you have to multiply it by the derivative of the inside function. Okay, you have to multiply that by the derivative of the inside function. Well, that was the inside functions right there. I need to take its derivative. And if I take the derivative of this stuff right here, that inside function, I'm just going to use the power rule. The 4 goes to the front, so it's going to be 4w. Then I'm going to subtract 1 from the 4. It's going to be a cubed. And then I'm going to go minus, the 5 goes to the front. 5 times 2 is 10. I'm sorry. Oop, forget that. I did not do that. I don't want to confuse you. Forget that for a second. Forget that. Let me pull out that inside function. This is the inside function. And we're going to take the derivative of that. You put the 4 in the front. Drop down the w. Subtract 1. So it's going to be 4w cubed minus. Then you see this 2w. Remember from our last video, if you just have a variable and you don't have an exponent, there's actually an exponent here, it's a 1. But if you just have a variable and you have an exponent of 1, the derivative is just this number out front. So the derivative of 2w is 2. So that is the derivative of the inside function. And that's what goes right here. You're going to go times 4w cubed minus 2. Okay? That's your chain rule. It takes a little bit of practice to get used to it because, it's a few steps. But just to recap what we did, you take the derivative of the outside function, which was something to the 5th power. That's what gave us this. Evaluate it at the inside function times the derivative of the inside function. And that's where we got that right there. Okay, and if we look at our answer choices, let's see which one matches up. Let's see. Well, it's not this one. It's not this one. It has to be one of these two. And it's not this one because they have brought the 5 outside the parentheses. And, well, actually, hold on a second. Yeah, it is that one. It's that one. Because this is my answer, and I should rewrite that the way you'll actually see it. It's going to be 5. You see how I have the box? Just put parentheses. So it'd be 5w to the 4th minus 2w parentheses to the 4 times 4w cubed minus 2. Because, in algebra, we don't see boxes. I was just kind of using the box to illustrate that was the inside function. But we're going to put parentheses around it. So it is, in fact, this one right here. That's your answer. It is, let me just make sure. Yeah, it's definitely this one. Let me look at that last one, because that's, yeah, it's not the last one. The last one's a trick answer, because a lot of people are going to pick, some people are going to pick that last one, this one right here, because they're going to think you can distribute this 5, but you can't. You can't distribute the 5 because you have to do the order of operations. Order of operations is PEMDAS. Parentheses come first, then your exponent comes next. So you have to do this first, then your multiplication comes next. So you have to do this to the 4th power before you can distribute. So you actually can't distribute like this. That's why this is not the answer. You cannot distribute that 5 before you do your exponent. So this is your answer. The last one's kind of a trick answer. Some people are going to pick that, but it's not the right answer. Let's see. Let's keep on going. Number 5. And let me make sure one thing. Hold on a second. Let me just check this. It's my first time seeing these, so I just want to make sure I didn't miss anything here. Oh, that's interesting, because let's go back to question 3. It says that we can do combinations of PC or QC. Well, we didn't use the product rule, so that won't come into play. And QC, we did not use the quotient rule, so there won't be any combinations yet. That one's just your chain rule. We did use the S. We did a chain rule, but we also used the S. But that's not one of the combinations they say you can pick. You can't pick C and S. So we should be good with just saying chain rule on that one. Let's keep on going up to here, because I think this one's going to be a combination. So let's take a look at this one. Number 5. If I look at number 5, This is the chain rule. This is the chain rule. This stuff in the box, that's your inside function. And then I'm going to call the inside function something. We have something to the fourth power. That's your outside function. Something being raised to the fourth power is your outside function. And this something, this stuff right here, is your inside function. That's your chain rule. So that's one thing you need to select. We know it's a chain rule. This. But look right here. It's also your quotient rule. Because you remember from the last video, if you have a fraction, we're going to have to use the quotient rule. So this is a combination. You're going to have to do the chain rule, and you're going to have to do the quotient rule. You have to do both of them. And hopefully they don't ask us to do that, because that's quite a bit of work. I mean, we could do it, but let's see what they ask next. Okay, so that's a combination. You're going to do the chain rule, because it's one function inside of another. And you're also going to do the quotient rule, because you have a quotient. Now, let's see if they're asking us to do it. I can't. Oh, they are. Okay, that's okay. Let's do it. Okay. Gonna do this one. Gotta be careful here. There's a lot of places you can make mistakes on this. And you know what? So this video doesn't get too long, I'm gonna stop it here, and I'm gonna make 2 videos. So this is our first half of our problems, and then in my second video I'm gonna pick up on this one, so my video doesn't get too long, and when I upload it, it will actually finish uploading. All right, so I will start my second video here in a minute.